Hello friends, in this video we will see the new methods of dimensional analysis, that is Buckingham's pi method. The Buckingham's pi theorem states that if there are n-dimensional variables involved in the phenomenon, which can be completely described by the n fundamental quantities or the dimensions such as mass, length, time, etc., and are related by the dimensional Hummel equation, then the relation among the n quantities can always be expressed in terms of exactly n dimensionless and independent pi terms. Mathematically, if any variable q1 depends on the independent variables q2, q3, q4 and qn, these are the independent variables. The function equation may be written as q1 is equal to function of q2, q3, q4 dash 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 q1. This is our equation number 1, which can be transformed to another functional relationship as f1 is a function of q1, q2, q3 dash 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 qn, which is equal to c, where c is a dimensionless constant. This is as if x is a function of y, which is equal to y square plus c, where x minus y square is a function of x and y, which is equal to c. In accordance with the pi theorem, that is Buckingham's pi theorem, a non-dimensional quantum equation can thus be obtained in the following form as f2 is a function of pi 1, pi 2, pi 3 dash 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 pi n minus n, which is equal to c1, wherein each dimensionless pi term is formed by combining n variables out of the total n variables with one of the remaining n minus 1 variable. These m variables, which appears repeatedly in each of the pi terms, are consequently called as repeating variables and are chosen from among the variables such that they together involve all the n fundamental quantities or dimensions, and they themselves do not form a dimensionless parameter. Thus, the different pi terms may be established as shown below. Here, equations have pi 1 is equal to q1 raised to a1 into q2 raised to b1, q1 raised to c1, dash 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 qm raised to m, and last one is qm plus 1. Similarly, we have the equation of pi 2, and by solving this, we have pi n minus m is equal to a1 raised to a n minus m, q2 raised to b n minus m, q1 raised to c n minus m. Similarly, we have qm raised to m n minus m into qn. In the above equation, each individual equation is dimensionless, and the exponents a, b, c, d, m, etc. are determined by the considering the dimensional homogeneity for each equation so that the pi term is dimensionless. Here, the final general equation for the phenomenon may then be obtained by expressing any one of the pi terms as a function of the others, which are as pi 1 is equal to function of pi 2, pi 3, pi 4, dash 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 pi n minus n. Similarly, we have pi 2 is equal to function of pi 1, pi 3, pi 4, dash 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 pi n minus n, or any other desired relationship may be obtained. The use of Buckingham's pi method may be now illustrated by means of example. So we will see the Buckingham's pi method with the example. Already we considered the example as the same problem of the flow through small orbits, which already learned or discussed under the Rayleigh's method. There are steps to adopt or solve the Buckingham's pi method. Here there is step 1. The physical quantities involved in the phenomenon are Q, that is discharge, small d, that is the diameter of orifice, capital H, that is the head constant. We have a small g, that is acceleration due to gravity. We have a mu, that is dynamic viscosity, and rho is the density. The functional equation for the discharge Q may be expressed as Q is a function of small t, capital H, small g, mu, and rho, which in its most general form may be obtained as F1 is a function of Q, small d, capital H, small g, mu, and rho, which is equal to C. C is the dimensionless constant. Here in this equation, we have 6 functions. Here, there are total number of variables n is equal to 6. And all these variables may be completely described by the 3 fundamental dimensions of either the MLT or FLT system. Hence, m is equal to 3. Therefore, there are n minus m is equal to 3 dimensionless pi terms. So that f2 there is a function of is equal to pi 1, pi 2, pi 3 is equal to c1. Step 2. In order to form these pi terms, we have to choose 3 repeating variables, since in this case m is equal to 3. As stated earlier, these variables should be such that among them contains all the 3 fundamental dimensions, and they themselves do not form a dimensionless parameter. Thus, let us choose rho, that is the density. We have the unit of density is Newton per mm square. From this, we have a dimension of density is n upon L cube. Thus, let us choose rho, that is density. We have a unit of density is Newton per mm cube. So, we have a dimension of density is n upon L cube. Similarly, for diameter of orifice small d, it is a L, and the gravitational acceleration is L upon t square, because we have the unit of gravitational acceleration is meter per second square. As repeating variables, since the above noted requirements are fulfilled by these rho, d, and g. In the step 3, since the physical quantities of dissimilar dimensions can neither be added nor be subtracted in terms of are expressed as the product of the following. We don't have to add this or subtract this. So we have and expressions are pi 1 is equal to rho raised to a1, p raised to b1, g raised to c1, and q. Similarly, pi 2 is equal to rho raised to a2, d raised to b2, g raised to c2 into mu. And pi 3 is equal to rho raised to a3, d raised to b3, g raised to c3 into h. In the step 4, expressing p1 dimensionally, pi 1 dimensionally in terms of M-vector system is pi 1 is equal to m raised to 0, l raised to 0, and p raised to 0, because it is dimensionless quantity, which is equal to rho raised to a2, that is m upon l cube raised to a2, diameter of orifice we have a dimension is l raised to b1, l upon t square raised to c1, l cube upon t raised to d1. We are equating the components of m, l, and t. We get for m, a1 is equal to 0. We have for l, 3a1 plus b1 plus c1 plus 3 equal to 0, and also for p we have minus 2c1 minus 1 is equal to 0. From these equation we get a1 is equal to 0, b1 is equal to minus 5 by 2, c1 is equal to minus 1 by 2. Hence, pi 1 is equal to q1 upon g raised to 1 by 2 upon d raised to 5 by 2. Similarly, we have for pi 1 is equal to rho raised to a2, d raised to b2, g raised to c2 into pi. Or in terms of dimension, m raised to 0, l raised to 0 and t raised to 0, because pi 2 is our dimensionless quantity. By putting the dimensions of each term, we got m upon l2 raised to a2, l raised to b2, l upon t square raised to c1 and m upon lt. By equating the exponent function of m, l and t, we get for m 0 is equal to a2 plus a1, a2 plus 1, sorry, l is equal to 0, which is equal to 3a2 plus b2 plus c2 minus 1, and minus 2c1 minus 1 is equal to 0. From which a2 is equal to minus 1, b2 is equal to minus 3 by 2, and c2 is equal to minus 1 by 2. Hence, pi 2 is equal to, we have mu upon rho into g raised to 1 by 2 upon d raised to 3 by 2. Lastly, we have pi 3. Similarly, we will calculate the dimensions of pi 3 is equal to m raised to 0, l raised to 0 and t raised to 0, which is equal to m upon l2 raised to a3, l raised to b3 and l upon t square raised to c3 and into l. By equating the components of m, l and t, we get for m a3 is equal to 0, for l minus 3a3 plus b3 plus c3 plus 1 is equal to 0. Similarly for t, we have minus 2c3 is equal to 0. From these equations, we get a3 equal to 0, b3 equal to minus 1 and c3 is equal to 0. Hence, we have a pi 3 is equal to h upon d. In the step 5, since f2 is a function of pi 1, pi 2, pi 3, which is equal to c1, by substituting we have f2 is a function of q upon g raised to 1 by 2 upon d raised to 5 by 2, mu upon rho g raised to 1 by 2 upon d raised to 3 by 2, and last the value of pi 3 is capital H upon small d, which is equal to c1. And we get q upon g raised to 1 by 2 upon d raised to 5 by 2 is equal to c1, and c2 is equal to mu upon rho g raised to 1 by 2 upon d raised to 3 by 2 comma h upon d, from which the expression in its usual form may be obtained, as we already learned in the earlier method, that is Rayleigh's method. We got the equation as similar. Thank you.